Hello guys, in this video I will be solving a problem related to dielectric laws and dissipation factor. The theory related to this topic was covered in my previous video and the video link is given in the description. So let's start. In this problem we are given an insulator which is composed of two parallel connected plain capacitors. Okay, and the capacitance values for both of these capacitors are given: C1 100 nanofarad, C2 200 nanofarad, and their loss angles delta 1 and delta 2 are given. So here you know that from the theory that in electrical equivalent model of an insulator we have two shunt elements, capacitance and conductance. But now here, instead of conductance, we are given the dissipation angles or loss angles of the insulators. But anyway, if we are given capacitance and if we are given the loss angles, we can determine the value of conductance from the formula, which is tangent of loss angle, tangent delta, is equal to G over B. So B is equal to omega C, so and delta is given, so we can determine the value of G as well. Anyway, so and then we are given electrode distance 3 millimeter, and we are given the applied voltage, which is 6 kilovolt at 50 hertz. In part 1, we are asked to find the insulator's dissipation factor, loss tangent of the um, full insulator, which is combination of two parallel insulations. So now we are given dissipation angles, okay, for both insulators separately. We cannot simply add them up to determine the dissipation angle of the overall insulator, but rather we need to solve it using these steps. Okay. So first I'm going to draw the equivalent circuit of the overall system. So now we have capacitance of insulator 1 and conductance of insulator 1. Then we have capacitance of another parallel insulator. Then we have conductance of the second insulator. And applied voltage is 6 kilovolt. And we have ground here. So this is C1, this is C2, this is G1, and this is G2. So we can further simplify this circuit such a way that we can only write equivalent capacitance and equivalent conductance of the overall system. Okay, and this will be our CI and this will be our GI. And if we draw the phasor diagram, and here we have 6 kilovolt. And if we draw the phasor diagram, so phasor diagram will look like this. So on the horizontal axis, we put GI, and on the vertical axis, we put acceptance. And here we have the total admittance, YI, and the total loss angle will be here delta, and tangent delta will be equal to GI over BI. Okay, so we will use these concepts. So in order to determine GI, we need to, again, G is equal to, as I wrote here, so G is equal to B multiplied by tangent delta. So it will be equal to B multiplied by tangent delta. So G1 for the insulator 1 will be equal to B1 tangent delta 1. Similarly, G2 will be equal to B2 tangent delta 2. Okay, and further B is equal to omega C. So it will be omega C1 tangent delta 1, and G2 will be equal to omega C2 tangent delta 2. So now our admittance, equivalent admittance, will be equal to the GI plus JPI, okay, which can further be written as omega CI tangent delta I plus, or tangent delta simply, plus J omega CI. And now our CI, because we have the CI is equivalent capacitance, which will be sum of capacitance C1 and C2 simply. Similarly, G will be the sum of G1 and G2. Okay, so we can use this expression. So we will have here G1 will be equal to omega Ci tangent delta I plus J omega plus susceptance will be omega Ci. Okay, so now we can put this as omega, and this one can be written as, so this is Gi, this is Gi, which is equal to G1 plus G2, exactly the same way as Ci is equal to C1 plus C2. So omega and C1 tangent delta 1 plus omega C2 tangent delta 2, because omega is same, so we can put omega outside. So it will be C2 tangent delta 2 plus J omega, and again here Ci can be written as sum of C1 and C2. Now this is our Gi, this is our Vi. So now in part A we were required to calculate the dissipation factor. So dissipation factor here will be tangent delta equivalent delta, and that will be equal to Gi over Bi. Okay, so we will put the values of Gi and Bi, omega C1 tangent delta 1 plus C2 tangent delta 2 divided by omega C1 plus C2. Omega will be cancelled with omega, and we are given the values of C1, C2 and delta 1 and delta 2. We can plug the values and we will get the dissipation factor as 0.093. So this is the answer of our first part. As dissipation factor is really small, it is less than 10%. So that means there is not much power loss in our insulator. Then in the second part, we are asked to find, in part B, we are asked to find the, the power loss, dielectric power loss, P, and capacitive reactive power, Q. Okay. So, and we are given the voltage, 6 kilovolt. So it is really easy to calculate these parameters. So for part B, we need to determine P and Q. Okay. So as we discussed in the theory, our complex power dissipated across the insulator is equal to U square multiplied by Y conjugate. And U is given as 6 kilovolt in the given statement. So we have 6 into 10 raised to the power 3 whole square, and we are given, and we determined the value of Y in part A. So we can use the same values what we determine in part A. And conjugate means we will invert the sign of our imaginary part. Okay, so that will be our omega C1 tangent delta 1 plus C2 tangent delta 2 minus j omega C1 plus C2. I just wrote the same expression but inverted the sign of the imaginary part. Okay. So we are given all the values in the problem. We have value of C1 delta 1, C2 delta 2, and instead of omega we are given frequency. Okay, we are given frequency equal to 50 hertz. So you can find the value of omega. Omega is equal to 2 pi f. Okay. So after putting all the values, we will get the answer as 317 minus j 3393. The units will be volt amperes. And the real part is P and the imaginary part is Q. And remember, we must have a negative sign in between. Why? Because here we don't have any inductive reactance. In dielectrics, we have the resistance or conductance and the capacitance. So we have capacitive reactance, and capacitive reactive power is always negative. So the dielectric power loss, P, or we can also say PD, is equal to 317 watt, and capacitive reactive power of the dielectric, QC, is equal to 3393 var. Okay, these are the answers. This is all. Thank you.